Okay, so here we have written the trigonometric table of all the angles. Okay, see from 0 degree to 330 degree. So the next angle will be 360 degree. That is a coterminal with 0 degree. So this cycle will keep repeating. Okay, so this is going to repeat for all the angles. So by which we can get a trigonometric table of all these common angles. We can get it. Fine. So now let us try to find out something called as the domain and range of trigonometric function of trigonometric ratios or functions, whatever we call it. Okay, we can call it function also because all function of x and y. Okay, so now let us. So what is the domain? That means what I am saying is, suppose you have a trigonometric function sin theta, cos theta, tan theta or something. So, and depending upon the values of theta, whatever the value can be theta. Okay, so this is going to have different values. We saw it here. Okay, so now these numbers are in what set? Means what's the numbers, in which number scale it is there. For example, we know the numbers, the type of numbers are, one is integer. Okay, integer goes from integer goes from the negative number, say some dot to -4 or -3, -2, all negative include -1, 0, 1, 2, 3, like that. Okay, and then we have the natural numbers, that is 1, 2, 3, 4, 5, and then we have the whole numbers, that is 0, 1, 2, 3, like that, and then we have the real numbers, that is -1, -4, -3, -2, and it will take the fraction numbers in between also. Okay, so I can't write out. There can be all infinite possible fractions in between this one. So, and this will be -1, 0, 1, 2, 3, and the fractions in between we should have. Okay, real number contains all the numbers. It has rationals and irrational numbers. All those things will be the real numbers. Okay, so now seeing this, we can see all the numbers, right? Suppose, for example, let us say sin theta. In which these values will fall in which numbers? Are they integers? Are they? They will be all be in the real number. Am I right? Say loudly. The real number. Okay. So, for example, so then we have sin theta. So let us see what is the domain of sin theta. Sin theta is an element of real numbers. Okay, sin theta will be element of real numbers. But remember, there's one thing, we are having some infinity, some minus infinity and plus infinities. Okay, infinity is not in anywhere else. Infinity is something undefined number. Okay, you can't consider infinity as a real number. Okay, sometimes mistakenly people consider infinity as a real number, but it is not correct. Okay, because infinity is undefined. So whenever infinity comes, that is undefined. Luckily, sin theta is not having any infinity. Am I right? So sin theta, if for whatever the theta, all sin theta will be element of R. So this gives you the domain. It's going to be element of R. And what is the range? So what is the maximum value of sin theta? 1. Correct? This all will be less than 1. Correct? Because this is root of 3 is equal to how much? You know what is the root of 3 value? Root of 3 will be 1.732 and root of 2 will be 1.414. Okay, typically. So this all will be less than 1. Okay, and the other range will be -1 because this all will be greater than -1. So your sin theta range is going to be -1 greater than sin theta is less than 1. So this is going to define your domain and the range of sin theta. Okay. So similarly, let us go for the cos theta. So when you go for cos theta, so what is the, again let us see cos theta. They all belong to a real number. Am I right? Nothing, there is no infinity or anything here. They all belongs to real number. So cos theta is an element of real number. And what is the range of cos theta? Again, the maximum value is 1 and the minimum value is minus 1. So minus 1 cos theta is less than 1. So this is the domain and range of the cos theta. So let's go for tan theta next. Tan theta. So what will be tan theta? So now, yeah, tan theta will be interesting because all tan theta are not a real numbers. Am I right? Because there are values where you have plus infinity and minus infinity. These values are not undefined. So if I exclude these values, then all these numbers are in a real number. Okay. So what happens? So what is it? How can we exclude? So this, for example, whenever it's pi by 2 and this is 3 pi by 2, and then if I go back, it will be going as a, because it's cyclic. Am I right? So we should want to draw the curve also. That will be better. Am I right? So what we have we have x minus x, y minus y, and this was the unit circle we had. Okay. So now tan theta is what? Which are the values tan theta will be infinity? Pi by 2. Okay. This is infinity, and then this is 3 pi by 2. Correct? This is minus infinity. So then if it goes again, what will be? 5 pi by 2. Correct? 3 pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, so all. So what happens? So for tan theta is equal to plus or minus infinity, for theta is equal to pi by 2 or 3 pi by 2 or 5 pi by 2, 7 pi by 2. So any odd multiple of pi by 2, tan theta is going to be infinity. Okay, so these cases, this is not going to be a real number. Okay, so then what we say is, so for if instead of writing like this, we can write theta is equal to 2n plus 1 pi by 2. Okay, so when theta is equal to 1 pi by 2, okay, tan theta is equal to plus minus infinity, where n is the integer which goes from, take some, is an integer, take any value of integer. Okay, if it is 0, it is pi by 2. If it is 1, it is 3 pi by 2. If it is minus 1, it is minus pi by 2. So you can have n is an integer, whatever we do. Okay, so the domain and range of tan theta will be, tan theta is an element of our real number if only when for theta is not equal to 2n plus 1 pi by 2, okay, and where n is an element of integer. So this gives you the domain of tan theta. So now let us go for the inverse functions, inverse trigonometric ratios, that is your cosec theta. Okay, so again, now if you see here cosec theta, so again here cosec theta, see cosec theta also there are some infinities, infinity, infinity. Okay, so when it is infinity, 0, pi, okay, 0, pi, and then 2 pi, 2 pi will be again cyclic, right? 0, pi, 2 pi, 3 pi, 4 pi, it goes on like that. Okay, so what we have, cosec theta is equal to plus infinity, just only one infinity, infinity when theta is equal to 0, pi, 2 pi, 3 pi, and go on, right? Or I can write it as, or we can write theta is equal to, when theta is equal to n pi, okay, and n is an integer. See, for negative angle also same case only. Negative is, whatever we are writing in the positive will be negative. Okay, here also in the table what we have done for all as, what is the values we have? We have done for the positive angle. So for negative angle we know the formula, right? Sine minus theta equal to minus sine theta, and cos minus theta equal to cos theta. You know, remember. So then I know all this, for all the negative angle I can use this formula and you can do that. Okay. So then this for also you can write one more, tan minus theta equal to minus tan theta. So this gives you the values for the negative numbers. Fine. So now what is coming here? So n is, for n equal to integer, this is going to be infinity. Therefore, the domain of cosec theta is an element of R if theta is not equal to, did I mention that? Yeah, theta is not equal to, what is that? Tell me. N pi. And n is an element of, tell me, I. Okay, so this is the range and the domain and the range of cosec theta. So similarly for your, what is the sec theta? Tell me.
Sec theta will be.
Sec theta also has some infinities, right? See, plus infinity. There are two infinities. So sec theta will be infinity. Then theta is equal to, what are the values? Pi by 2.
And 3 pi by 2.
3 pi by 2, and not just that, it goes on, right? Pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. Then it goes on cycling, no? It keeps on going. 5 pi by 2, 7 pi by 2, and go on. Or other hand, or in that case, theta is equal to, this is an odd multiple of pi by 2. We know that how to write, right? 2n plus 1, this is an odd number, pi by 2, and where n is an element of integer. Okay, it shall be equal to element of integer. Okay, so the domain of sec theta is an element of real number, because all the other cases are real numbers. If theta is not equal to, what is that? 2n plus 1 pi by 2. Okay, and for n is an element of I. Okay, so, and yeah, I missed one more thing. Okay, the tan theta, so this is a domain. What is the range of tan theta? Tan theta can go from all values. You got it? So from minus infinity to plus infinity, you can take all values. So range is the entire real numbers of the range. Okay, there is no limit for tan theta. All the real numbers are the range. On the other hand, cosec theta, there is a range. If you see cosec theta, right? These all are greater than 1. Okay? These all are greater, because I wrote, this is 1.732. These all are greater than 1. Where cosec theta, yeah. Sorry, we are doing cosec theta. And similarly, these all are smaller than minus 1. When you go for beyond this infinity, these all are smaller than minus 1.
They're greater than minus 1.
Oh, sorry, yeah, greater than minus 1. Okay? Here also greater than 1. No, smaller than minus 1. Nah? This is 2 by root of 3.
Okay,
No, it's smaller than minus 1. Okay, here it is greater than minus 1, smaller than minus 1. So means cosec theta will be all the positive real numbers ahead of 1 and all the negative real numbers behind the smaller than the minus 1. So, or in other words, we can have the range. So therefore we can define the range as, what is the range we can have? Yeah, I can write down the range also. So the range of cosec theta will be, I can take a mod of cosec theta, that should be, what should be? It should be greater than or equal to 1. Am I right? Plus mod. Mod means it can be plus or minus, whatever the value. Okay, so this gives you the range of your cosec theta. Similarly, for sec theta also, if let us look for the sec theta also, the same thing comes there also. See, these all are greater than 1. Okay? And these all are smaller than 1. Isn't it? So this is again greater than 1. So the same thing happens for the sec theta also. It can be greater than 1 or less than minus 1, nothing in between. So therefore sec theta also will have an range. That's what? That will be mod of sec theta should be greater than or equal to 1. Okay? And then the last trigonometric ratio is cot. So shall we write it here itself? Yeah, we have some space, we will use this space. So now we are going to do the cot theta. Okay, let us find out cot. What's the trigonometric? Cot theta. Cot theta, again there are infinities. Therefore, not all cot theta is going to be an element of real number. Only except these infinities, they can be real number. So what is that value? So when is the cot theta can be infinity?
0 degree.
Cot theta will be infinity when theta equal to 0,
Or theta equal to pi.
0, pi, 2 pi, correct? 3 pi and go on, right? Because it's 0, pi, 2 pi, 3 pi, so pi, go on. For all these values it will always be. So these are basically coterminals, na? So all the coterminals will have the same values. Fine. So or on the other hand, I can write theta. So this is just theta equal to n pi, where n is an element of integer. Okay. And if you see again the cot theta range can go from 0 to infinities from both the sides. Okay, so cot theta again will have contain all the real numbers. Okay, the range is entire real numbers is the range of cot theta. Okay, correct? Yeah. So therefore the cot theta, the domain and range of cot theta is cot theta is an element of real number if theta is not equal to n pi, okay, and n is an element of integer. Okay, you got it? So this defines the domain and range of all the trigonometric ratios. Okay.